Hi, everybody, and welcome to Cloud Native London. We are going to kick off in about 15 minutes. So in the meantime, please listen to some music. Feel free to just chillax. And if you want to come and watch with us together, please go to this link, oyshell.com/r, and we'll be on in about 5-10 minutes to welcome our speakers. Hi everyone, this is Cheryl. We're going to start in about 1 minute. Hi folks, and welcome to Cloud Native London. So we are a strong, open, diverse developer community around cloud native and the platform and technologies, mostly in London right now, everywhere. My name is Cheryl. I'm the VP of Ecosystem at the Cloud Native Computing Foundation, which is the home of Kubernetes, Prometheus, Envoy, and lots of other open source projects. You can find me on Twitter at @OiCheryl. So now I want you to tell me a little bit about you. So please grab your phone, laptop, tablet, whatever, and go to this URL, oicheryl.com/p. And I'm going to ask you a couple of questions about you and a couple of questions about how you use Cloud Native. You don't need to install anything. It will just redirect you to this site where you can put in your name and then you can come and say hello to everybody else who's listening. Okay, so oicheryl.com/p. And let's go for the first question. Is this your first time attending Cloud Native London? You should have 2 buttons, yes or no. Just if you've been here before, let me know. Cool, and I'm going to leave this for about 20 seconds because there's a little bit of a lag between Zoom and YouTube, but I love seeing these results come in. Looks like we're about 2/3, maybe 3/4 returning, about 1/4 first time, which is amazing. Cool, yeses are coming back in. Okay, I'll give everyone 10 more seconds to figure out this link. If you lost that link from before, you can also go to this slightly longer polev.com/CherylHung link, which will redirect you to the same poll that we're using now. Okay, looks like we're about 70% returning, 30% new, so awesome. Really great to see that. Let's go to the next question. All right, where are you right now? So you should see a map, just put a point wherever you are. When we first started this, I only showed the UK, but then people started telling me, hey, we're joining from other countries. So I thought I'd give everybody a world map and see where people are. Definitely UK focused, but I see France and a couple of others in Europe. Okay, maybe next time I'll go back to having a slightly bigger map of the UK because I'd love to see where everybody is actually sitting right now. Cool. Couple more coming in. Oh, someone is in the middle of the sea here. I think you can fix your answer though. I think you can change your answer if that's you. All right, nice. Got a mixture of UK and a couple of people from Europe. So this is actually one of the things that I do love about going online. We can have more people from other countries joining, not just London. All right, next question. What is your job title? So pick the thing that is closest to what you do. So architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. Okay, results coming in. Architect and SRE DevOps coming into the lead. I think this usually maps pretty well with what I've seen from past meetups. SRE and architect tend to be the leading two, with a mix of other things. If you have a chat window as well, it would be great if you want to tell people exactly what you do, if you're in the other, or if you're something that's not quite covered by any of these options. Cool, I think the answers have slowed down. So I would like now to welcome our three speakers. So first we have Simon, who's going to tell us about cloud native at a 150-year-old retail institution, the good, the bad, and the ugly. Next, we have Rafał, who's going to tell us about architectural caching patterns for Kubernetes. And then we will take a 15-minute break. And then we'll come back for our third speaker, Jesus, who's going to talk to us about securing DevOps and CI/CD pipelines in the cloud. And then we are going to wrap up at 9 p.m. UK time. So I have a couple of questions for you from our speakers. And I would like Simon, Rafał, and Jesus to come and just chat with me about the results as they come in. So these questions are what our speakers want to know from you. So first question is, how many engineers do you think Sainsbury's Tech has hired since March? And I think, Simon, this one is yours.
It is, and the results still coming in.
I have no idea what to expect from this at all. So I'm really interested to hear what the answer is.
Well, I think there's a lot of people changing answers. It's moving a lot. I thought the 50 to 100 was going pretty strong at the beginning. Seems like people. It was.
I mean, Sainsbury's must have had a crazy busy year.
We have indeed, yes. Yeah, it's been a very interesting time to be in retail, and certainly a sort of primary supermarket, primary supply chain. So yeah.
Yeah, definitely in the UK, some of the news about the websites going down and having to implement queues and for customers. It's been fascinating.
Okay, I think we've stabilised. All right, so yeah, good spread there. Well, it was 80 at the beginning of December when we got the last number of figures, and that's since March. So that's 80 colleagues that have joined, onboarded, never been in the office. Completely virtual experience, and it's been a very, very interesting time.
I would love to hear about it, because onboarding virtually must be a bit of a change as well.
Awesome. We're getting quite slick now.
Well, 15% of people thought 0, which was maybe pessimistic. Now that I know it's 80. Awesome, though. Really great to hear that. Looking forward to hearing you talk about the challenges. So we're going to go to our second question, and this one comes from Rafał. So what programming languages are supported by Hazelcast? I'm not even going to try and read out these solutions, but hi.
Hello, everyone. Let's wait since the answers are still coming. Yes, I see most people go for the third answer here, but let's wait some more.
Yeah, I'm having to look at it hard just to be like, which languages are in which options?
Yeah. You have to exclude and see which one is the right option.
What is your favorite programming language? Just out of curiosity.
Yeah, I'm Java developer, I have the biggest Java background, so I still love Java, even though people nowadays, they are more going for Go programming. So I also do like Go, but mostly Java. And my background is I'm very backend developer, so I'm not so much into Node.js and JavaScript.
I'm with you actually on that. I find front-end programming so much harder than back-end programming.
Yeah, it's the same for me. So many libraries and it's changing so quickly. Java is at least it's stable. I mean, not only Java, but like the backend languages are more stable with time. Okay, I think we have the answers. So it's still changing. So actually the right answer is the answer number 2, which means that we don't have a Ruby client, but we do have native clients for Java, C++, .NET, Python, Go, and Node.js. So most people did not guess correctly. That's what I can say.
I feel like this is a hard question to ask.
Yeah, I guess so. It's still changing, you see. So
I think this is cheating. If you can vote after you know the answer, is cheating. All right. Thank you. Okay, people definitely cheating now. Look at this. Okay, I'm going to move us on to the third question. All right, so have you ever considered or implemented real operational and not best practices cybersecurity remediations on your DevOps environments? Okay, wow, so you've got a few answers here. So we're going from yes, we've checked and implemented all kinds of cybersecurity, only open source, only best practices, nothing at all. Cybersecurity is not important, and I don't know what cybersecurity is. Jesus, this is your question. Hey, you there? Okay. I don't hear you for the moment, but Simon and Rafał, I wonder if you have any thoughts or opinions about cybersecurity.
Well, it's really important. It's shifting left and doing it early enough and getting that feedback and integrating it in is an important thing to do. And I'm pleased to see that we got 75% in the yeses there.
Yeah, absolutely. This 55% is higher than I thought it would be. So it's a very good sign. Cool. Okay, I think the answers have slowed down now. So I want to say thank you to all for kind of playing along with us and telling us a bit about yourself and how you're using Cloud Native. With that, I want to say thank you to our sponsors who help us keep this running, keep this going. And Lizzie, I'd like to welcome from Technovo to say a few words.
Hi, thanks, Cheryl. Yeah, I'm Lizzie from Technovo. We're a challenger digital consultancy based in London Bridge, and I'm marketing manager there. We also run a community initiative called Tech Camp, which aims to ensure tech events are open and accessible for all. If you want any further information, you can follow us on LinkedIn, find me on LinkedIn or in the chat. And we've also got a Slack community channel as well. Really looking forward to hearing from the speakers. Back to you.
Awesome. Thank you so much, Lizzie. And Humio, unfortunately, could not send a speaker tonight, but they've sent me a few words they'd like me to read out to you, which is Humio is a time series log management solution for unrestricted event analysis scaling to multi-terabytes per day on-premise or hosted. So thank you so much for both Technovo and Humio for sponsoring our meetup. If you would like to come and speak or sponsor, then please go to this link, oishell.com/cloudnativelondon. We're currently booked up for speakers until the end of 2021, so please plan ahead if you want to come and speak. We would love to have you. We're particularly happy to welcome first-timers, people who are not so confident with speaking. Just hit me up on Twitter or whatever, on Slack, and let me know. Okay, I'm going to take a momentary selfie. So I'm going to take this selfie from Rambly. Okay, so people who are on that link, oyshow.com/r, give me 2 seconds and I will be right there with you. Ta-da. Okay, this is for the purposes of the blog post afterwards. Okay, all set. Thank you so much. And that is it. So with that, I would like to hand over to our first speaker, Simon. Over to you.
Okay, let's just get the slides up, hopefully. How's it going? Have you got the slides?
Yeah, looks good.
Brilliant. Well, I'll get an early thing in. We talked about recruiting earlier. We're still recruiting at pace. So Sainsburys.jobs. And if I can get it to move on. So, well, it probably doesn't matter if I can't. Okay, yep, so I'm Simon Perry. I'm an engineering manager at Sainsbury's. I've had a long and varied career in tech, from a developer to starting my own business, owning part of another, and then going back to the tech again. I joined Sainsbury's Tech back in September 2019, initially to look after one team. And since then, I've taken on more responsibility, and I'm now heading up 7 teams, including one of our cloud engineering functions. So this isn't going to be the most technical talk you're going to get, because I'm an engineering manager and I don't get to do the exciting stuff as much as maybe I'd like to anymore. But yeah, I'll try and keep it snappy and entertaining and give you an idea of what tech and particularly cloud native is like at Sainsbury's. It's going to be quite sort of broad and general, but yeah, just to give you an idea and an organisation at our scale. So Sainsbury's Tech is relatively new. So Sainsbury's had their 150th birthday back in May 2019, and it was about that time that Sainsbury's Tech was first being discussed. So the idea was to create a tech-first function for the whole of the Sainsbury's group, which brought all the brands together. So Sainsbury's, Argos, Nectar, Habitat, 2 Clothing, and this will be this was for the first time. So from that point forwards, things really happened at pace, and Sainsbury's Tech went from that idea to a reality and was launched at the beginning of September 2019. So we started off as 4 CTO pillars, so data, digital, retail, and corporate, and roughly 1,800 colleagues. So the majority of this talk is going to focus on my experience in the commercial part of the retail pillar. So just to give you a little bit of detail, data is our sort of data and analytics side. Digital is our customer-facing web, so grocery online, 2 Clothing, and the digital offerings. Retail is our sort of retail operations, how the business runs, and within retail there's several pillars in there. So we've got supply chain, logistics, and commercial. And then corporate is our sort of corporate IT function. So that's platforms, systems, IT support, telephones, IVRs, that type of thing. So, since last September before last, now we've achieved a huge amount. So we've created domains and long-lived stable teams, and we've brought together teams from different companies and cultures. We've taken sort of different ways of working from across those companies or brands, and we've adopted the best that we found, and sometimes we've done something completely different, and we're sort of continuing to evolve and improve. So I wanted to sort of give the good, the bad, and the ugly, and an honest insight into the way that we work. And one of the reasons that I joined Sainsbury's was because I wanted to find a company that resonated with me, with my culture and my values. And I'm very pleased to say that with Sainsbury's I have. One of the biggest things for Sainsbury's is diversity and inclusion. We serve the nation, and our customers are incredibly diverse. And that's why, Cloud Native London's such a good fit with the aligning goal there. And obviously we were hosting the Cloud Native meetups for a while, pre-COVID. So, we've got some good company values that resonate. We trust in each other. We do things at pace. And, there's a lot of, sort of respect and sort of collegial ways of working, I suppose. In the tech ways, we've got our tech principles, we've got guidelines, we've got some secure software delivery lifecycle guidelines, and we've got Tech Radar as a way to share, the tech that we're working with and adopting. So I think I've already mentioned autonomy. We have a lot of it. And I think that was probably one of the biggest differences between the two big tech functions when we merged. I think Sainsbury's had, a very sort of autonomous, sort of completely autonomous model. And Argos was, a lot of autonomy, but when it came to the platform and the hosting, it was very much a PaaS model. Whereas Sainsbury's was, we're going cloud, but anything goes. So, as I said before, our teams are based on long-lived, they're long-lived teams based around domains, and each of those teams works, I suppose, like a mini startup. So we have cross-functional teams, and cross-functional teams where cloud plays a pivotal role. We had the poll earlier that we discussed security, and we're certainly doing our best to shift left on that. And we have colleagues from security that join our stand-ups and, are in there right at the start, when we're doing our ceremonies, when we're doing our planning, and giving their expertise and input. So our aim is to automate everything. We embrace infrastructure as code and automated pipelines. We've got quite broad and I suppose broadly similar tech stacks, but we've got a lot of autonomy, a lot of flexibility. So there's a lot of different things in the mix. So our main languages are JavaScript, Java, Python, Scala. We've got some .NET and that, but not so much in the domain that I work in. So the domain that I work in is probably about 200 colleagues, and about 140 of those are permanent rather than partner colleagues. In terms of the sort of the clouds, we are multi-cloud, multi-vendor, but the majority of our presence is on AWS. We've seen an evolution, and this is, I guess, pre-Sainsbury's tech, but post the start of the move to the cloud. So the evolution's been from EC2 through to Kubernetes, and now EKS is very widely adopted. Some of the teams have had great success with Lambdas, and some have found that they haven't been a good fit at all. Obviously that's another heated talk all in itself. We've used almost every CI tool out there, from Circle CI through to Code Deploy. Now mostly we're settled on Jenkins. Some of our teams have really pushed the boundaries for hosting COTS packages, so commercial off the shelf packages that were never designed to run in the cloud. And they've taken those, they've containerized them, we're running them under Kubernetes in some instances. And that's proved to be a really valuable exercise, and has given us some control and ability to meet some of the demands that we've had over the last 9 months with a spike. And as you can imagine, last year was a very busy, a crazy time to be in a supermarket. Towards the end of February, beginning of March, we saw massive spikes in volumes, in some cases like 1,000%, almost overnight. And our systems cope with that amazingly well. And a lot of the reason for that was our adoption of cloud. Oops, too far. So it's not all plain sailing. We're in a large company, and we've got a lot of autonomy. I mentioned that before. So how do we share best practice? Well, part of, again, back to our values, having a growth mindset, supporting learning, supporting development is really important. We have a lot of guilds, we have community of practices, we run internal training, we have plural site and that type of thing. There's a whole nother talk there about, how tight we want to be on that best practice. The secure software delivery lifecycle that I mentioned, we've got some checks and measures that we want, our teams to implement, but the tools that they use to do that and how they put that together, there is, autonomy there. And my personal view on that is that, the flexibility that we get from this approach outweighs the possible overhead of doing things twice or doing things differently. I suppose the other thing that we've got, there's a lot of ways of doing the same thing, and you can bet that between our teams we've probably found them and we're probably doing them. That can make it onboarding a little bit harder, or a bit of a learning curve. But again, my personal view, we've got that flexibility. We've also got several platform as a services, and they're sort of aging in time. So as I say, that was very much the Argos approach. We've got some others within the business as well. And there's a big push at the moment to, look at those to decide what the next generation is going to be. And, we're approaching that, very much in an MVP fashion, and looking at what the best thing to do and how to provide that for the business is. As you can imagine, we've got a huge cloud real estate, and we've run into every sort of problem of scale that you can imagine, from running out of IPs to particularly when we had a disaster recovery day just to check that we could work remotely in early February. We realized in some of the areas the amount of stress we were putting on those systems. As it turns out, for the majority of us, we did that disaster recovery and we never went back to the office. Since then we've pushed the boundaries of all the communication, and we've covered a lot of problems. From the updates of our corporate IT equipment being tied to being on premises, to those huge volume of calls, or hits to our web real estate and our systems and our logistics. We've grown the online business, by several factors over that time, and just made a lot of really positive changes quickly to the business. So the ugly. I think I'm rattling through this quite quickly, so I hope you're thinking of some good questions for me. I'm pleased to say this isn't a huge section. We are a large institution, and sometimes that makes things harder than they would be in a startup or a small institution. The good news is that we're not afraid to challenge that, and that's positively encouraged. We're very much looking at how we can reduce any sort of friction or institutional treacle. I think I've heard it being called. Sometimes it's just hard to know where to start when you want to do something for the first time. If you're looking to introduce a new commercial package, there's some checks and measures you've got to go through to do that. You've got to engage with different parts of the business, and it's hard to find that out, and that can be a little bit frustrating and time consuming to find the right things. We are a 150-year-old business. A lot of functions are sort of embedded in legacy ways. We've still got a lot of legacy within the business, but a lot of what we're working on, particularly in the commercial domain, is to engineer new microservice event-based systems to replace that legacy real estate. We're working in agile ways, and that's not always been a comfortable fit for some of the change management or planning process. So we're that's another area where we're continuing to improve and refine. We've taken a data-driven approach, and we've got sort of Sainsbury's tech-wide certainly goal to adopt DORA metrics. And we're finding that that's really paying dividends. We can see how often our teams are shipping, and that's from multiple times a day to weekly, and sometimes further out. We've got different the future's here. It's just not evenly distributed, to quote William Gibson. But being able to prove our change failure rate, our mean time to recovery, has been really valuable for us to be able to increase the cadence in our teams, and to increase the happiness of our development team as well, because they all want to they all want to ship, they all want their code to be used and get the feedback. Sometimes our best efforts have had some unintended consequences. So we did some hardening of the IAM roles, which was done centrally, and that took a lot of teams by surprise, and it broke a lot of things, and that took us a while to sort of work around that. But on the whole, I am very pleased to say that the ugly section is really very small. It's a vibrant, happy, and good place to work, and virtually every tech challenge is available for us. So that's about me. So I'm slides are stuck again, I think, but open for questions.
Awesome. Thank you so much, Simon. If I can get you to stop sharing your screen for a moment.
Yeah. There you go.
Perfect. I am going to bring up some polls for questions. So if you have questions for Simon, please go to this link, pollev.com/Cheryl, and then you should be able to type stuff in, and we should be able to see it and answer any questions. You kind of teased something at the end, actually, Simon, that I was kind of hoping to hear about. You said you got all sorts of challenges that are coming up that people can work on. Like, what's something that you think is an interesting challenge that you see for this year?
Excellent question. So, where to start? We have a massive transformation program going on at the moment that we call Futures, and that's I suppose I alluded to it a little bit there, where we're replacing a lot of our legacy systems, and it's where we've brought all the different parts of the Sainsbury's brands and sort of different technologies together. We've got something like 7 different warehouse management systems. We've got 4 retail management systems, and our idea, and the aim is to have, new, flexible microservices. Everything is, event-based. Our messaging's via Kafka. We've got some huge scale engineering challenges and problems, and there's a lot of opportunity in there. So, the size of the data set, for instance, where we're doing pricing, we've got literally millions of products, and those product prices change all the time. But we've got to manage that data. We've got to make insights from that data. And we've got to be the authoritative source of truth for that data. There's a lot of work obviously going on around Brexit as things change, so we need to react to those. So yeah, certainly no shortage of challenges.
Okay, perfect. I see some people asking questions coming in. I'd like people to vote up and down if they can on the existing questions, so we can get Simon to answer the ones most people are interested in. So let's go from the top. Can you please expand on your adoption of Kubernetes, and what is the good, the bad, the ugly of EKS?
EKS, definitely the good. That's certainly where it sits. Not having to manage the control plane is a huge bonus for us. Kubernetes has been a really good fit in terms of being able to, empower the teams to create the, infrastructure that they need to run the services. We're particularly in commercial, we're, using Kubernetes, we use Helm, and sort of GitOps infrastructure as code, and that certainly I feel is a big sort of part of how we can operate at the speed that we do, and how we've managed to support the changes that we have.
And kind of related to that, what do you use for logging and monitoring?
Yeah, great question. So we've got New Relic that we use sort of centrally, and that gives us some insights sort of broadly, and then again we've got a lot of autonomy, and we've got a lot of different things. So we've got some Datadog in the mix, we've got some Kibana, we've got some Prometheus. We've got a real mix there as well.
A little bit of everything, it sounds like.
Mm-hmm.
How are you using multi-cloud? How are you using them, I guess, each cloud, and deciding which workloads to run on which cloud? Yeah,
so as I say, we're predominantly on AWS. We have got quite a lot of .NET in part of the business, not the area that I work, and that tends to be on Azure with Azure DevOps. And Google Cloud is a relatively new introduction, and we're using Google Cloud for some of our data insights and our data products. So we've got a partnership there that looks at the market, looks at what products are hot and trending, and the prices of those, and that I believe runs on GCP.
Okay, I'm going to try and go through more of these questions in the next 5 minutes. So what tools do you use for configuration management?
So configuration management, we use Terraform, we use Git. I suppose they're the main ones. As I say, we use Helm, we use trying to think of the other one that we were looking at, I heard the other day. But yeah, as I say, a lot of autonomy, a lot of different ones.
And I guess related to that, so how do you prioritize dealing with tech debt against delivering new business functionality?
So that's the perennial one. I'm very pleased to say that, well, I mean, what I've just described is, our transformation program is effectively tackling tech debt. We're removing and replacing a lot of mainframe systems, a lot of legacy systems. But that's not to say that we haven't got that tech debt, and we don't build up that tech debt in the software that we're building now. And that's, that's always a business decision, and it's something that you need to go into with your eyes open, and explain and negotiate and get agreement about how you're going to tackle it and when you're going to tackle it. And that's one of the things that I like is we've got that autonomy, we've got that trust, and we do go through and prioritize that debt, and we've got the ability to tackle that. It's about communication, it's about informing your stakeholders, but it's probably the best situation I've been in, in terms of understanding and willingness to deal with it.
This question's been rising up as I've been watching. So how do you manage the multiple language stacks and solutions that power your technology?
Lightly. So, as I explained, we've got principles, we've got some guidelines, we've got tech radar. So, a lot of it is about empowering the teams to make the right choices and to be able to justify the choices that they're making. We've got some strategic technical reviews, so we've got some steering groups, if there's a big decision to be made, and where we're, not necessarily a decision, it's where we want visibility and, buy-in. So, that's the way that we do it. I mean, as I say, personally, I think having the autonomy and the flexibility pays dividends over and above, any sort of standardization. For me, I think that's a bit of a myth. It's important for us, as engineering managers to be, supporting decisions and to be making sure that, what's being introduced is, being thought through, that we can support it. For instance, certain languages are a nightmare to hire for, and are hotter than others. And, you've got to factor that in, and you've got to challenge the team when those sort of ideas come up. But, it very much is the right language technology for the job.
Makes sense. Do you use a service mesh for connecting on-prem and cloud, and which did you choose?
We have got some teams that are investigating service mesh at the moment, but we're not using them for connecting on-prem and cloud. We don't have a huge amount of on-prem to cloud connectivity. But yeah, certainly service mesh is something that's been sort of tickling on my personal tech radar for a while. And, I can see a lot of value there. And particularly, with the journey that we're going on with the microservices being event-based, some of the observability and metrics that you can get from service mesh, I think could be very useful for us going forwards.
Be very interested to see if your answer to this is different in another 6 months or a year or whatever. And speaking of a year in, if you could go back to September 2019, what would you do differently between lift and shift and building and refactoring?
Oh, I'm going to be contentious here. I think if I went back to September 2019, kill off the lambdas earlier.
Oh, okay. Tell me more.
It's just that we've found that we've had, every sort of problem that you can have with a lambda we've hit. We've hit the startup times, we've hit the fact that it's costing us far more to run than we thought it was because we couldn't stay in the free tier, to running out of memory, to yeah, it's just, you know, as I say, we've had some real success stories, but we've had some stinkers too. And yeah, that's my personal opinion, not Sainsbury's. But
all right, last question. What's the next big technologies that you want to apply?
That's an excellent question. I mean, you know, I suppose we're doing so many of them at the moment. You know, we've with the advent of Sainsbury's Tech, we've built out a data capability and function. So, you know, we're doing the ML. You know, yeah, it's, you know, a lot of the time I think we're pretty close to the edge. You know, I think we'll probably go back to the service mesh one. As I say, I can certainly see, yeah, I can certainly see some real advantages from that, and the fact that, you know, we can put them in alongside what we've already got to get that observability that we, you know, may not be able to get another way. So I think that's the one to watch.
Fantastic. Thank you so much, Simon. I really, really appreciate you presenting and sharing all of your insights. So thank you so much.
It's a pleasure. Thanks for the opportunity.
With that, I'd like to hand over to our second speaker of the evening. So Rafał.
Hello, everyone.
Ready?
Yes, sure. Let me screen share and I'm ready. So hello, everyone. Again, I'm speaking to you from Poland, from Krakow. And I would like to tell you about caching and especially about architectural pattern for caching in the world of Kubernetes and microservices. But first, a few words about myself. So I'm an integration team lead at Hazelcast. Before Hazelcast, I worked at Google and CERN. I'm also an author of the book Continuous Delivery with Docker and Jenkins. And from time to time, I do conference speaking, but on a daily basis, I'm an engineer. And as I said, I live in Krakow in Poland. A few words about Hazelcast. So you may know Hazelcast from our main product, which is a library for caching, for distributed locking, for everything. It's like we call it Swiss knife for distributed computing. But we also have another product, which is Hazelcast Jet, which is a library for stream processing. And we have Hazelcast Cloud, which is Hazelcast put as a service. And we are a distributed company. We all of us work remotely, and we always worked remotely. So I'm in Poland, but we have people all over the world. Our agenda for today is pretty simple. So there will be a short introduction, and then I will walk through all caching patterns that you can use in your system. Now, while I'll be talking, I would like you to think about two things. So the first thing is, which of this pattern do you use in your system? Because like for sure you use one of them because you most probably use caching, and this list is complete. And the second thing is, would it make sense for me, for my system, to move to some other pattern, some other topology? And with this question, I leave you and I start with the introduction. So this is a classic microservice system. So we have a lot of services written in different programming languages. Services can have versions. They use each other. So there is a lot of things happening in a microservice world. Another question is where to put the caching layer. Should the caching layer be inside of each service, or maybe as a separate cache server? Or maybe we should put cache in front of each service. And that is what this talk will be about. So the first pattern we will discuss, the simplest one, is embedded cache. Embedded cache means we put cache inside our service. So a diagram looks as follows. A request goes to our system. it goes to the Kubernetes service. It's forwarded to one of the Kubernetes pod. It's forwarded to the application. And inside the application, there is a cache put as a library. And now application checks, okay, have I already executed such a request? If yes, return the cached value. If no, do some business logic, put the value into the cache and return the response. So the idea here is super simple. It's so simple that you can even implement it on your own without any library. If you happen to use Java, that could be your implementation. You can put concurrent hash map. Then if cache contains the request, return the value from the cache. If no, do some processing with the request, put the value into the cache and return the response. You can write it in any programming language. However, you better not do it on your own, because like simple collection may sound like a good solution for caching. However, simple collection is not a cache. It's not a cache because it has no eviction policies, no max size limit, no statistics, no cache load, there's no expiration time, no notification mechanism. So it misses a lot of features that are needed for a proper cache. You're way better off using some caching library. Like for Java, if you happen to use Java, it's Guava is a very good library for simple caching, or where you can define all these missing features while creating your cache. Another good library is EHCache. We can even move this idea one step, one abstraction level higher, and put the caching into the framework level, into the application framework level. Like if you happen to use Spring, like most Java people, you can actually add only cacheable keyword, and now the framework will take care of the caching. So it will every call to the method getBook name by ISBN will first check, okay, if the given ISBN is already found in the cache called books. If yes, return the cached value. Only if it's not found, then execute the method find book in slow source. However, be careful because Spring, for some reason, they use concurrent hash map by default. So you're better off changing your cache manager for your application. So we have our embedded cache. It's simple as you can imagine. We have caching, everything is good. Now imagine that there is a request coming to our system again. Now it's load balanced to the application, let's say application on the top. We didn't found this request in the cache, so we do some business logic, we put it into cache, return the response. Now the same request can go to our system, but this time it's load balanced to the application at the bottom. Now we need to execute the business logic again, because these two caches, they don't know about each other. They are completely separate. That is why one of the improvements to the embedded cache is to use embedded distributed cache. In the terms of the topology, it's still the same. However, we will just use a different library, which is a distributed caching library. In this case, we'll use Hazelcast, which is just a library, but it provides a way to cluster your cache. So the flow is still the same. We still do exactly the same. However, this time, every cache in every application replica forms one consistent caching layer with other caches. So no matter to which application, with which application we interact, we use the same cache. And Hazelcast is just a library. So if you would like to use it with Spring, you just have to specify, okay, I would like to use Hazelcast as a cache manager, and that's it. All the application looks exactly the same. Now you may wonder, like, how is possible? I mean, because the problem with the forming a cluster with the caching is how to discover how to make the discovery. So we in Hazelcast, we provide a number of plugins. We actually have a SPI for the plugin, so you can even write your own plugin for your environment, but we have actually a lot of plugins. So you just specify in which environment you are running in, and your caches will find themselves automatically to form one consistent caching cluster. If there is no plugin for your environment, you can always piggyback on Euroka or Zookeeper for the discovery. For details, we publish a lot of blog posts on how to configure this. Short like pros and cons of embedded cache and embedded distributed cache. So the good thing about embedded cache is the cache goes together with application, so you actually don't have to manage this separately. Also, the cache is together with application. It means that you can have very low latency data access. And usually it does not require any ops team, separate ops team or a DevOps effort, because the cache, it's just together with your application. So you write application, you have it there. From the downsides, the management of the cache is not flexible, meaning that if you would like to scale up your cache, you need to do it together with your application replicas. So it's sometimes it's not what you would like to do. Also, since we use cache as a library, it's limited to the language of your application. So if you use Java or any JVM based, you need to use a library, caching library, which is written in something compiled to the Java bytecode. One more con is that data is collocated with applications, which is usually not a problem for small applications, but if you work in a big enterprise, big enterprises, they don't like it because they don't want to, and because of some security reasons, and also they don't want to store data together with the application. Going further, so we covered embedded cache. So the next pattern, the next topology of caching that you can use in your system is client server. So client server is kind of a database style. So you set up your cache server and then use cache client to connect to the server. So the flow is as follows. Request goes to our system, it goes to the Kubernetes service, it's forwarded to one of the application, and now the application uses cache client to connect to the cache server, which is deployed somewhere. It can be deployed on Kubernetes or somewhere else. Usually in Kubernetes, you will deploy it as a stateful set in your Kubernetes cluster. So as I told you, it's kind of a database style. And if you look at this diagram, there are two main differences between client server and embedded cache. One difference is that now we have this entity on our diagram, and this entity means we need to manage this separately. Meaning we scale it separately, we need to think about security. So it requires some maybe ops team or maybe just the DevOps effort from your developers. But there is another thing that is different between this diagram and the embedded cache. And this is this part. So now we use cache client to connect to the cache server. And that means that you can use any programming language you want, because there is a well-defined protocol between client and servers. You are no longer bound to the same language of your application. And that is a very common strategy, that you have microservices written in different programming languages, and that they access your cache using cache client. That is such a common approach that most solutions, actually most caching solutions, they, like the most well-known is Redis. So you cannot really embed Redis in a simple manner to your application or in any native way, because I guess Redis is written, I guess, in C, so you cannot embed it in your Java or Go application. And that is also the case with Memcache. So with Redis Memcache, you will always use the client-server topology. Now, if we stick to this, to the Hazelcast example of the client-server, so if you would like to deploy it on Kubernetes, we provide a Helm chart. So with one command, you can have a cache server deployed into your Kubernetes cluster. We also provide an operator if you prefer. How to configure the client? So if the client, if we stick to the Spring example, all you need to configure is, okay, I would like to use Kubernetes config, meaning Kubernetes plugin, and enable this, and your client will automatically find the server. So as simple as that, you can deploy it in your Kubernetes cluster, and the client will find the server, and all is good. Now in this client server mode, this client server topology, like server is like what we see in like big enterprises. It's like cache server is usually maintained by and managed by a separate team usually. So we can actually take this client server pattern and move one way further, and instead of taking care of the cache server inside our organization, move it into the cloud. So cloud is, again, it's like another pattern, but it's very similar to client server. The difference is that now you don't have to manage your server part, but you just pay the cloud provider to manage it for yourself, which is usually way cheaper because the cloud, I mean, the cloud, they know how to manage this the best. How to configure this in your application? So we in Hazelcast Cloud do something what most actually cloud solutions do. I think MongoDB is the same. So you set up your cluster in the cloud, and then take the discovery token, put the discovery token into your configuration, and that's it. Your client will automatically discover the server and connect into it. So pros and cons of client server and cloud caching. From the good sides, data is separated from the application. There is a separate management possible between you can manage your cache server separately, and it's programming language agnostic. From the downsides, usually it requires separate ops effort, or you need to pay for the cloud. And higher latency. In general, you have to, when you split your caching to the client and server part, no matter if it's on premises or it's in the cloud, you have to think about latency more. Because before your cache was in your application, latency was good. That was all good. But now we are in the caching domain. This is the domain that it's very latency fragile. It's very like you need to have low latency for caching. That is the whole idea for caching. That is why if you set up your on-premises cache server, you need to make sure that your cache server is in the same local network than your application. Because otherwise the application, in this caching domain, even one router hop is a lot. Now, what happens if in the cloud? So in the cloud, what we do in Hazelcast is we deploy for you caching server in your cloud provider of choice. So we may deploy a cache server on AWS. Because if your applications are in AWS, you would like your cache server to be on AWS. Also, you'd better create it in the same region where your application is, because the other region will be latency will be super high. Also, we provide a way to make a VPC peering between the VPC, virtual network, where the cache server is located, and your application, so that they are in a one virtual network. So there is not even one router hop between your application and the cache server. So if you choose client server or cloud, you need to think more about latency. It's not always necessarily higher, but you have to think about it more. Okay, let's move to something. So you may say like, okay, embedded cache, client server, these are very old concepts. But not, so now let's talk about something new. So sidecar, cache as a sidecar. So sidecar is new because the sidecar pattern in general, it came together with the container environments. It's very, very widely used in Kubernetes. It's not only, sidecar is not only for Kubernetes, but it's very, even now associated with Kubernetes. So how it looks like. So this time request goes to our system. It's forwarded to one of the Kubernetes pod. And in the Kubernetes pod, we have two containers this time. One is our application container, which is a normal thing. But we also have a second container, which is cache server. And now all these cache servers between different pods, they form one consistent caching cluster. And the application can connect to the cache using localhost, because every container in a pod is deployed, they can access each other using localhost. So this solution is actually somehow similar to embedded, somehow similar to the client server. It is similar to embedded because you are guaranteed that your cache is in the same physical machine, because Kubernetes guarantees that all containers deployed in one pod will end up in the same physical machine. They scale up and down together, and there is no discovery needed because you have your cache available at the local host. However, it's also similar to client server because you can use different programming languages. So you can use different for the client, different for the cache server, because after all, they use cache client, well-defined protocol between client and the server. How the configuration looks like. So in our cache client configuration, we just specify a static, okay, connect to the local host. That's it. We always know that the cache is available at the local host. Our Kubernetes configuration. So we need to specify two containers. One is our application container with our application business logic, and the second one is our cache server. Pros and cons of this sidecar caching. So from the good side, configuration is very simple. It's programming language agnostic. We have low latency and some isolation of data in application. It's on the container level. From the downsides, we again do not have flexible management because cache goes together with our application, and data is after all collocated with one application pod. The last caching pattern for today is something completely different. It is something completely different because so far, your application was always aware that such a thing as a cache exists. Now we will change it. Now we will put cache in front of the application, so the application will not even know that such thing as a caching even exists. So it can look like that. Request goes to our system, and just before the load balancer or after load balancer, it can be even in your ingress for Kubernetes, you have your caching layer. And now if the value is found in the cache, we don't even go further. We don't even touch the application. However, if the value is not found in the cache, only then we go to the application. So cache is kind of cache is in the proxy. A very good solution and mature is Nginx, because Nginx is everywhere, especially in the Kubernetes world. You will find Nginx everywhere. So you can just specify in your Nginx configuration, okay, I would like to get my value cached, and that's it. you will everything that will come through Nginx will have a caching inside. However, Nginx has some maybe not problems, but some characteristics that you may want to think about something else. One thing is only for HTTP, which is usually not a big deal. But something more important is that Nginx is not distributed, which may be the problem, and it's not highly available, which also may be a problem. And the data is stored on a disk. It's not necessarily stored on a disk, but it can be, if you have too much data, it can be stored on a disk, which is not the case, for example, in Hazelcast, where we always keep the data in memory, so you have a predictable data access time. Now, the last variant of this reverse proxy caching, which be combining this with a sidecar and putting reverse proxy as a sidecar. How it looks like. So this is our diagram. So request goes to the Kubernetes service, it's forwarded to the Kubernetes pod. And now inside the Kubernetes pod, this time it's not the application that receives the request, but this is the reverse proxy cache container. So it's like a kind of interceptor for your application that checks, okay, do I have such value cached? If yes, don't even bother to go to the application. And like this solution in general, this reverse proxy idea and reverse proxy sidecar idea, so putting cache in front of your application, in general, it has some good sides and bad sides. So starting from what is good about putting cache in front of application. Let's look at the diagram we've seen at the beginning of this presentation. So this is a classic. This is how every microservice system looks like nowadays. So different services, different programming languages, different versions, they use each other. You know, if you add some even Istio, then you can even have some even more complicated paths, because maybe they can use partly this version, partly other version of the service. Now, the good thing about reverse proxy caching is that you can look at the diagram of your system and say, I would like to introduce caching here and here. And you don't even have to touch the code of your service. You don't even need to change anything in any service. In a declarative manner, on the configuration level, you introduce caching. So you improve the performance of your system. And that is the beauty of the reverse proxy caching. Now, how it looks like in the configuration. So usually for reverse proxy sidecar caching, you will need two containers. One will be your application, starting from the bottom. Second one would be this reverse proxy sidecar cache. And you will also need some init networking container to say, okay, every call from outside, it goes to the caching proxy container, and every call from the inside goes to the application. So to tweak the IP tables. And that's it. You can deploy it that way. Now, if you look at this diagram, it may make you think about like Istio actually, because like Istio, for a long time, they didn't support like caching, but not so long time ago, they closed the GitHub issue to support caching. So you will soon be able to use the caching with Istio. So this will be first really mature reverse proxy sidecar caching, because until then there is no mature solution. We did a prototype in Hazelcast, but there is nothing you can really use in production. But there's also some, speaking about reverse proxy caching, there are some bad sides of the using, about the thing that application does not know about your your caching layer. So if you detach caching from your application, there's one thing that becomes way more difficult, and that is cache invalidation. And actually, if you look anywhere on the internet, like what is the most difficult part of the caching, everyone will tell you the same. It's cache invalidation, meaning when to decide that your value in the cache is already stale, that you doesn't make sense to use it. It's outdated. You should perform the computation again. And now, if the application is aware of the caching, you can use some business logic to say, okay, I would, if something happens, then okay, invalidate the cache. However, if the cache is in front of your application, then you are limited to basically what HTTP offers, so timeouts, e-tags, basically timeouts, and that's it. Short summary of a reverse proxy and reverse proxy sidecar caching. So from the good side, and the reason why you will use it, it's the configuration based, so there is no need to change your application. It's programming language agnostic. It's everything agnostic. Your application does not even know about caching. And it's very consistent with the containers and microservice world. Especially now when it was implemented in Istio, I really believe that will be the way a lot of people will do caching in Kubernetes soon. From the downsides, difficult to invalidate, no mature solutions yet, and it's protocol based, which is probably not such a big deal, but still. And like this, we covered all caching patterns, all caching topologies you can use in your system. So as a short summary, what I propose as a short summary, it's decision tree which can help you decide which cache to use. It will be simplified, oversimplified, but at least it can give you direction where to look for. So while choosing, the first question you can ask is, does my application need to be aware of caching? If no, am I an early adopter? If no, use reverse proxy, probably with Nginx. If yes, you can use reverse proxy sidecar, either with some prototype things or in Istio as soon as it's available. Now, if your application needs to be aware of the caching, then the next question is, do I have a lot of data or do I have some security restrictions? If no, should it be language agnostic? If no, use embedded distributed cache. If yes, use sidecar. Now, if you have a lot of data or you basically work in a big enterprise, then the last question you need to ask is my deployment cloud? If no, use client server. If your deployment is cloud, just use a cloud cache as a service. And the last slide for this presentation is a few resources. The first one is our blog post about using Hazelcast as a sidecar. Second one is our prototype for Hazelcast reverse proxy sidecar caching. Third one is it's not really related to this talk, but it's a very good blog post about caching best practices. And the last link is a video talk about using Nginx as a reverse proxy caching. And with this last slide, I would like to thank you for listening. It was a pleasure to tell you about caching.
Fantastic. Thank you so much for sharing, Rafał. Really appreciate it. We are unfortunately out of time for questions, but I hope people can contact you on Twitter and whatever else for.
Sure.
Fantastic.
Thank you.
Thank you so much. All right, we're going to take a 10-minute break now. So we're going to come back at 8:30 p.m. UK time. Please feel free to grab a drink, just chill out, and we'll be back shortly. Hi, folks, and welcome back. We are about to kick off with our third speaker. So I would like to welcome Jesus. Are you ready to share your screen and present?
Yes. Can you hear me now?
Yes.
Yes, I am able to share now. Is it being shared now?
Yep, all looks good.
I'll just move this to another side here. It's all good now?
All yours.
Good to go. Okay. Well, thank you very much for spending the time and still being here at 9:30 CET time to 8:30. Thank you very much for spending the time and actually making the effort. And thanks for the whole team of Cloud Native Foundation and Cloud Native London, again, for the opportunity to speak and to pass some knowledge through these presentations. So I'm going to make it quick because it's very late, and it's a more simplified presentation with a lot of technical stuff, but we're going to go through it. So this one is about an update on the previous talk I gave about securing the DevOps CI/CD pipelines in the cloud. The cloud is, as we know, it could be your computers installed somewhere. It could be our computers, could be somebody's computers. It doesn't matter. We put stuff somewhere and we run it. And when we are developing and building solutions, we tend to make sure that we want them to be secure. So I'm going to talk a little bit and give you like a quick overview about what do we have in our hands at the moment, and with what we have, what have we used up to now to deploy and deliver these solutions, and how can we secure them. So we started with physical servers ages ago, moved to virtual, then to cloud. And then at some point, the resources that we use in the cloud, obviously, they became too fat and too heavy to use and to work with. And the concept of containers, which is coming from a long time ago, was actually democratized, and it became something that was able to be used by everybody. And in our case now, this is the point where we are stopping with this, the point where we're gonna have a conversation focusing on the pipelines that we use for development, and how do we actually use containers to push those solutions and apps that we actually build. So there's one point that we always like to talk about, which is the fact that we have the key word that's called DevOps. And for us is a buzzword, is a word that we use, but we need to understand exactly from where it's coming. So it's been always something that was there. It was always visible for us. We always use it. Every time that we deployed solutions, we built them, we developed them at the time. We were using DevOps. We were working under the DevOps model, but we weren't able to give it a name at that point. It came to the point where the developers had to bring more easiness and have better facilities to do their job, instead of being monolithic and build stuff in a very compartmentalized blocks, into something that was more streamlined, easy, and eventually fast. This is where we come with the point where the DevOps is just moving a model that existed before, that was built by the developers, but it went to the developers. It did not evolve to the people that was going to secure them. So when we look at this diagram, this is what we have to have in mind all the time. We start continuously in our continuous integration and continuous delivery to code, to eventually build, to test, and that's where we are in the actually development side with the planning. And then we get into the releasing our application, deploying the application, operating the application, monitoring. When we look into this into this model, that this is what we use today now everywhere, the key element that we have is there are so many blocks, and I need to know, what do I use in each of these blocks? when I want to actually make something work. Because before we could say, well, I had Visual Studio and I was working with the language and I had my IDE to build my software. I would call my libraries and then I would build all the code. I would put it just in a build server, even locally, and then I would run the build. I would wait, I would get my product when everything was compiled. But now we have a completely different ecosystem where it's not for me to do it. For me, is to be part of a full process and a journey. And that's what we get within all the picture of all the different solutions that we can have around. And that's crazy because this is only a small part of what we can actually find in the DevOps whole ecosystem. This is just a small part of it. The reality is that when we look into it in a deep dive view of what is inside the DevOps ecosystem, we get to the CNCF Cloud Native Landscape. This has been updated to the 6th of January of 2021, where you see all the possible solutions that we have at the moment when it comes to platform or databases, or when it comes to messaging, or for example, when it comes to integration and delivery. You see Jenkins, which is one of the key ones that we have. It's only one of the possible solutions that we have. We could use Weave, we could use Argo. There are so many of them that are into place and they are playing a lot. And you see, when you look into that, it's crazy what we can actually be able to use. And not everybody is doing it on the same way. And there is no standards or a standard on what you should use or what you should not. And that's only on the part that is tied to what we have on the platforms application. But then we get to the serverless, and then we have, which is the evolution. Instead of having to code everything, I get pieces of running software and running solutions statute in certain areas, and I actually create code that runs with demands of the execution of what I already have purchased or established myself. And then even in that case, we got so many of them. So it is not actually an easy ecosystem to follow. One of the things that happens when we are in the DevOps environment and when we are building our actual and creating our infrastructure in our companies for the CI and CD development is that our DevOps teams and the DevOps people, what they want is to build securely. They want to ship fast because it's time is of the essence. We cannot just stay looking into the code that we are building and waiting for approvals and waiting for a whole process. We need to ship very fast. Not only ship fast, ship secure, and then we need to run it in many platforms. So we want to create content that could be cross-platform. So we don't want to build for only one. For example, we don't want to have an app that is only for Android. We want to have it for Android, for iOS. We want apps that can run across any browser, that can use any possible applications. And we want to do that in one shot. And it needs to be optimized, and eventually it needs to be secure. This is the problem, that we fall into this situation where the companies, they actually make money out of what they are able to produce. What they produce is what they actually sell. What they sell is what actually pays back the people within the company. It's a basic business model. It's called capitalism. You produce stuff, you sell it, and then you are able to pay back and make a profit out of it. But this is the situation we have. We have a CISO who is actually behind the security. We have a DevOps manager who actually is unable to follow up the standards and to keep the pace of the security. Whether we're going to discuss just in a second later, if security should follow the DevOps or DevOps should follow the security. It's not actually very important if we do it in reverse. We're going to see the points. We have security conditions at the moment that are actually, and especially, for example, the COVID-19 challenges that have brought during the last year is a big change on the needs and the dynamics. And the infrastructure has changed, the speed of the changes has been very fast, and the sophistication of the threats that have appeared across the applications and the services, we can see it straightforward with plenty of solutions that had to change and adapt very fast. Typical example was Zoom, that had plenty of security issues because nobody did any auditing into the code and any auditing into the application to make sure that the application, when it went mainstream because of the confinement, it ended up being totally open for plenty of potential attacks, impersonation, lack of security controls. And this is what we get with these typical examples. And the confinement was just one, for me, was a pusher for proving that you have to be more conscious about security than you were before. The problem of modern coding is that we need to build stuff that is pretty fast and accurate to the needs of the business. And this is the reason why, for example, we create microservices that we use to push user applications to depend on. We containerize our apps. And the problems that we see at the moment and the points that we see is that the legacy security vendors and the legacy security players, they innovate very slowly, and we don't have really the old players being as fast and as transversal as the new players, or just the innovators in security for the developers, CI/CD. The speed of coding is gone very fast, and the code that we produce also, we produce more code. It's like the waste in the world. We do a lot of waste, and over the years we've been doing and creating more waste. That's what happens with applications. We create more and more and more amount of code. The techniques have changed enormously. They are more complex. The controls that we had, in the past, there were a lot of, they were generating a lot of issues, and they still generate a lot of issues today when we want to control the code that we're building, the complexity, the processes that have been built into place for the developers that become very complex. When we try to apply controls to detect if there are issues or not, it's a killer. Teams complain, developers complain. The outcome, for example, of a lot of applications that get fast built, fast coded, they have created 100 of supporting solutions. This is pointing exactly to the slides about the CNCF. Every time there was a problem in the DevOps ecosystem, somebody built a solution for it. Somebody needed a special feature somewhere, and somebody came with an idea of, oh, I'm going to build a startup that's going to produce this product, which is going to solve this particular problem. And this is why we have hundreds of solutions in the market. If you take the same for the cloud native applications, you take the same ecosystem and you bring it into the on-premises, for example, and you put it into the normal infrastructure solutions that we have at the moment, we don't really have that ecosystem. It's probably divided by 1/10. We'll go always the same players and mostly the same solutions with different names and different flavors, but this stays much more homogeneous. The amount of code that we see that we create today as waste that we create in the world creates a lot of insecure code. Something that's very good between the last years and up to now is that we control a lot. So there's a mistake in the slide. It should be uncontrolled. What it says is the process of the containerizing app is now mostly controlled. It should not say mostly uncontrolled. It's mostly controlled. So we are missing some parts. 2 years ago, I gave this talk, and it was not the same state that we can see today. The adoption of containers and microservices and CI/CD on the way that we know it, and using cloud services, it's gone crazy. So most of the people are doing it now. It's very difficult to find people who are not adopted partially a process and a framework of CI/CD development in the cloud. And the vendors are adapting their solutions to have open source solutions or commercial solutions to provide security that fits into a part of that ecosystem. The landscape of the DevOps, when it comes to security, produces a lot of customer pain. And when I say customer there, means the DevOps is the customer, the producer of the security solutions is bringing that pain into them. An example, the DevOps, they get a lot of increased security and compliance requirement, which means that they have to do a lot more work that they did not expect to have. And that is a lot of time proving compliance and proving that they're doing right the development and the processes are meeting the security requirements. The security is also slowing down the people itself, which means that the company is missing time to market, or they're missing features and fixing issues, because security is very difficult to put when it's not fully automated. And it's quite very difficult to fully automate when you are not heterogeneous. And when you're not homogeneous, what you have is a lot of heterogeneous different environments that are all not compelled to be standardized across different companies. Then we get to the problem when they have incompatible tools that have not supported, and they're not optimized for that particular cloud I'm using, or for the way and the tools that I'm actually using in my CI/CD pipeline. And that means that we have a super overhead on security because every environment needs to be tested. We need to actually try to figure out how are we going to fix the security solutions to adapt them into the existing environments. And that creates a lot of pain. Now let's talk about the word security and how do we move it across the DevOps. So let's say that the DevOps is a cycle. The CI/CD is a full cycle that goes in a beautiful infinite loop. And at some point, security needs to appear and needs to be applied. If we talk about DevOps Sec, which is one of the schools that are available there, it means that we are putting the security at the very end. So when all discrete work has already been done, so we already finished the development, we have done all the operations and the orchestration, we're just monitoring. The application is already there. My product is outside, people has got it in their phones, everything is downloaded, people are consuming. But my big issue is that at that stage, I need to run my security solutions. And at that stage, the only thing I can do is look into what's available, look into something that is running already, and say, well, we find so many security issues, but you know what? We're going to patch that on the next release. Let's take notes about what we found, and let's move into the next release. And this is the thing that becomes very problematic, because we don't look into the process. So we are not actually measuring through any type of KPIs what are we doing in each of the phases of the development. And we just look at the end. Final product, is it good or bad? Oh, it's bad, but it doesn't matter. We already released it a few hours before, and we did it this night. The test says that there are 20 vulnerabilities. We will see that into the next release. If we move the sec word into the middle, so DevSec, DevSecOps, which is very cool, it's not bad. It's usually where most of the people who are actually implementing security, that's where they're sitting. They're sitting just in the middle. What they do is that they break down the development and the operations, and they just crash the security in the middle. So it's pretty cool, because already they have a team that is working in security. They have tools that do work into the code. So we do that because we know that the devs are not aware about security and cybersecurity and threat issues and threat management, and they don't understand what are they going to get, what they're going to see when they have security tools into that. So what it happens is that once the development is already finished, and we are getting into the point where we're going to start pushing and providing the business solution, the business product to the customers, we do the analysis. And if we find some errors there or some issues, and if we find something that is non-compliant, we stop the process and we send the information back to the developers, and they can just rebuild again and publish or let's say submit their applications to be tested again. But at that point, the problem is that we are not getting the security prioritized as we want. Now let's move the word security into the beginning. This is the one I love, because this is really this is the situation that we should all be. That's the situation where we should find ourselves when we have a DevOps environment. We should not be into, I'm going to see it in the middle or I'm going to see it at the very end. In Sec DevOps, what we do is we integrate all the InfoSec governance and all the InfoSec processes, which brings then all the InfoSec functional and operational solutions, processes, frameworks, governance, policies, applications, tools, all based on security. We bring it into the beginning. So we are actually teaching. That could start, for example, by teaching developers about how to code securely. And once we finish that part of teaching, we moved into, for example, saying, now you're going to use a tool within your development environment that's going to test, for example, or many tools that are going to test, for example, your code. Is going to test also the libraries that you're using. It's going to tell you if, for example, you're actually putting the wrong information inside the code. You're not actually encrypting certain content. So it goes through the whole process, and especially it goes in the middle. It goes when the developer submits, it is tested, and when it gets into the operationalization and the deployment, we keep on monitoring. So this is where we should be, all of us. Unfortunately, we are more in the DevSecOps than we are in the SecDevOps. Samples and typical attacks, because it's very nice to talk about. The DevOps ecosystem and the DevOps operations and frameworks that we use and how it looks like. But then people are going to be, well, what the hell are the attacks that we're talking about? I want to see examples. I want to see what is the risk. I don't see the risk. I've been doing this for 5 years. I never heard about any risks. It's totally normal. Risks that we have, for example, are the fact that when I am building my code and, for example, I'm publishing and submitting it, there could be an infection inside my Docker hosts and inside, for example, other containers, malicious containers that could be there creating fork bombs. For example, the fork bombs, what they're going to do is create a limited amount of malicious processes and just kill my servers delivering the application. Or, for example, I could unfortunately get my code infected, and I could have code inside my application communicated and trying to infect other containers. That's also what we call the unauthorized pivot traffic, which basically means an application that they publish, it could be trying to, while it's running in the bases that it's running, is going to try to move across and try to find vulnerabilities in other containers, for example, and automatically do what we call the phase 4, which is the lateral movement in an advanced persistent threat. Rogue images, I can end up having images running in my repositories that are not expected to be there. Somebody pushed them there, or even replace mine with fake ones that I actually use and publish. Let's say that, for example, I want to publish a particular database, and I just have a rogue image that is replacing one of my databases images that I have. And I think I'm publishing a right one for my application, but in reality, I'm not. I'm publishing one that is giving me the service, but is infected. I can have, for example, images that are orphaned, that they don't have actually, they don't come from actually no development pipeline, but they stay there, and they could be even malicious too. I could have rogue processes or libraries that I'm pushing, which have actually hooks into malicious code. So when I'm using it, I'm actually just opening myself to an attack. I'm probably opening myself to be contacted by a malicious actor to abuse my resources. Persistent volume mounts, the volumes I'm mounting that are going to be used by my containerized applications, they happen to be persistent, which means that they are not only during the life duration of the container, is they remain there after, which means that they can actually be infected with code. And every time somebody mounts it, I can just, boom, launch malicious code. There is also the CCH, which is the cryptojacking container host. This is something we see a lot, which basically means that I'm launching container images into container hosts, containerization hosts that are used for crypto mining, or having persistent malware infections, APTs, which are going just to trigger C2C communications back to the command and control servers, or fileless attack. That's what we're going to talk actually in the next example. So we see all of this as typical attacks that we can find into a pipeline that we can be victim of. Let's see an example from the company Aquasec, which is called the Ginseng malware attack. So the key thing is pretty interesting, because when we look into it, okay, and one of the nice things about it is basically that it just finds that there is a Docker daemon that has an OpenAP port. So basically the attacker just connect to the host, and that's something that you need to have in mind, because we need to, something I'm going to talk later is about what do you need to do in what are the elements that you need to follow in order to make sure that all of the things that happen here will never happen. So the Docker daemon is attacked. It makes the attacker create a new container, which is the Ubuntu container. When he launches the container, he's going to download a shell script from this IP address, which is actually a malicious IP address. He's going to run that shell script, which is going to download the Kinsing malware. That's the point where you are completely done. This is the point, this is the line where you are, it's over. The malware has been downloaded and it becomes red, it runs the malware. But look at this, it's not only running the malware, it's actually creating a cron tab, okay, and making an entry to make sure that it's persistent, which means that it doesn't matter if you actually say, oh, I'm going to stop this process, it's going to be able to relaunch itself again. So it downloads the Kinsing malware, and this is when everything goes wrong. The malware is there, you can see it, detected by Clamap, which is the open source anti-malware. It then downloads a lateral movement script, because obviously he has to spread itself across the different other container running and try to see if there are other hosts open that it can be infected. And then it runs the crypto miner, starts communicating back with the command and control to the IP address that we see there, 193.33.87.219. It keeps on communicating to other with the crypto miner, it just keeps on mining and abusing your resources. It tries to communicate to other IP addresses, and then launch again the lateral script, which then tries to figure out credential and keys if you have not protected them, and just tries then to move container to container, host to host, and try to spread itself as much as possible. And it works, and it's a very is a real example of the type of attacks that you can actually experiment when you are not controlling not only your infrastructure in the cloud or locally, but also the process. Mitre attack is actually a database that let me put it that way. For you guys that are entering in security, it's very important that you start adopting and learning the Mitre framework. And why is that? This is because the Mitre framework is going to give you a better approach to the visualization of a thread of the threads. Instead of having all the technicalities of the previous slide, you have here actually all of the possible type of tactics and the effect of the previous attack explaining the tactics. When you look into the tactics, you're gonna exactly know what you need to secure and where you need to go to actually pinpoint the source of the issues within your infrastructure. So how do we fix these issues? How do we fix that issue? But basically, it's pretty simple. We need to put a security framework, a global security framework that is frictionless for the developers. We need to make sure that it integrates properly into the pipelines, because otherwise we're not going to make it. We're not going to be able to run it. We need to make sure that it's looking into the early stages of a potential infection and providing the security at the early stages, not in the latest. We need to make sure that it's also monitoring what happens after the deployment and the delivery. We need to also make sure that it's looking into the historical events. So it's able to look into the logs and is able to look into what has been happening in the past and what is happening in the future to create a behavioral baseline. It needs to be as transparent as possible so that the developers and the operations don't feel the impact and don't feel any pain. And it needs to be fast to deploy. If we're going to talk about deploying this in 18 months, but well, we better find another job and do something different, because we're not going to be in security very long, and you're not going to be in developing and making money out of this too long. This is what I was talking about before. So we had this attack, and people are going to come and say, well, Jesus, I need to know exactly what you're going to do into my pipelines. What can I actually do? So let's start with some bullet points that we need to keep. And I think that this is a slide that you should actually take home and put it in a frame in the beginning for a few months until you are able to tick the boxes. The first thing is you have a pipeline. Harden the pipeline. Hardening is something very interesting because it's the process of actually locking down to the minimum level of permissions and the minimum level of openness every element and object that you're using in your environment. Your host repositories, the configuration managers, the build servers, everything. Is you sending me a chat? Oh, Simon probably says to drop off. Okay. I didn't see the chat, sorry. So that's the first thing. The monitoring, the second element you do, you need to monitor the pipeline. So it's a mandatory point where you need to have a visibility in the whole pipeline from the first code that is written in the hands of a developer in the screen. I mean, like the screen I'm watching now, at the time that the person is writing, to the point that somebody is running the application. Well, you're gonna monitor it in my phone. I hope so, but at the point that somebody is actually getting the application published, for example, in the App Store or in the Google Play Store. You have to perform arbitrary audits. You remember this thing about, it's very common in the USA, that they knock on your door at job and they say, hey, it's pee time. And you know what that means? That means it's straightforward. They're going to bring you to a room and they're going to make you pee, and there's a drug test. And that's something that doesn't happen here in Europe. I hope so, because it's crazy to knock on your door and say like, no, let's go to the toilet. You want to pee in front of me. So that's crazy. Well, arbitrary audits in security is exactly the same thing. Somebody at the moment, and at some point, is going to walk into the whole development room and is going to say, guys, hands off of the computers. We're going to do an audit. It's not like this, but it's a little bit like a metaphor. We just launch an audit when nobody's expecting it. And then we come out with the results, because that's the way we're going to reduce the attack surface. Using trusted secret managers. I see still people that are not actually not using at all any management for the keys, for the credentials, and for the secrets. Airbag, be able to actually create role-based access control. What's the hell about looking in your entire toolchain and not being able to know who is doing what? So auditing authorization is mandatory. We need to know who is doing what and when. Immutable logs. I need to have the ability to, every log that is created in my CI/CD pipeline needs to be logged and needs to be immutable. There are ways to do that, which is called the persistent storage, that you're able to write, but you're not able to actually rewrite the content. So nobody can modify or tamper with the content. Container security, which is something that we have seen already, and code analysis tools, which means that you need to analyze the code. And let's have a look into that. So how do we get into the CI/CD pipeline, and how do we look into the different elements that we have before the pre-commit to production? So we look into different elements, for example, the static analysis the static analysis for the code. Okay, then we get to the source code analysis. Then we get into, again, the static. Then we get into the interactive, and then we get into the dynamic. And at the end, we get into monitoring, and then we do the pen testing and the red teaming, which means that when the app is finally ready to go or is running in my company, I just go against it and I just like bam, bam, pen test it. Let's have a look into something that's pretty interesting about this process. Let's look into what is SAST versus SCA and what is SAST versus DAST. So if I look into SAST and I compare it with SCA, and I give credit to the people who are behind this beautiful slide. They're not mine. I don't have the time to draw so beautifully. There's a lot of people who have the free time to do all the logos and the colors. One is looking into, the SAST is looking into your code proprietary, needs to access the code, has a very complicated remediation processes because it needs to change everything that you build. It cannot very easily integrate it with the software development life cycle. It's prone to high false positives, but we still have to use it. It's time consuming. That's why you have to have people running these solutions instead of the developers. So beside the developers, and it only covers a part of it, which is mostly the 10 to 20% of the code base. SCA is the part of the open source. And we're going to tell me, why should we do one or the other? No, you don't need to do SAST or SCA. You need to do both. Because you're going to be running proprietary code, but you're going to be running open source libraries, and you're going to take open source code to run it. So you're going to be able to do SCA, which does exactly the same thing. It just looks into the open source. It's going to be easier because the open source code is already published and documented. So it's going to be more faster to fix regarding the vulnerabilities. It covers the full software development life cycle. It has no false positive because what you get there is the vulnerabilities as they are. So there will be no zero positives. So the code is going to present the real vulnerabilities, accurate, not false positives. What's the difference? Open source means that I'm touching code that is not your code that you develop. The reason why in the code that you develop there are high false positives is because I don't know what you're planning to code. So every time you're coding something, every company, every stage that they do something, they do a different type of code. There is no build, there is no impact on the build or on the repositories, and it covers all the possible open source risks. That's pretty interesting. So we need to combine both of them. And then in the line and in the discussion that I had in the slide before, I was talking about DAST also. EAST is a fix between SAST and DAST, so it stays in the middle. Instead, it does a little bit of SAST and a little bit of DAST. We're going to see what it does now. So SAST versus DAST, I'm going to just move it into the other side. DAST is a dynamic, okay? So it's the dynamic application security testing. So for us, it's the black box. What I do is with SAST, I do white boxing, which means that I look into the whole application, I look into the source code, and I go like, okay? While in the other side, okay, in DAST, what I do is black boxing. So I need to run the application, I need to see it, and I do a pure black box, which means I don't know anything about it, but I spend more time finding the unknown into it. You need to do it when you need to really analyze the application and the code that you're and the solution that you're planning to build to bring into the market. If we look into the pipeline, the security controls that we can put into it, and this is a classical example where we see the committing with some examples. I just took the most obvious, the building, the pushing, and the running. You have the build scanning. So for example, integration with Jenkins. You have the registry scanning. That's where you're going to push or whatever you're building yourself. Then you're going to have an admission control where you're going to find your orchestrators, and then you're going to decide to actually push the application. And at that point, when I stop there and I have the runtime, because that's the pipeline scanning, then I got my runtime protection. This is when I'm going to do the analysis of the security for containers, for trying to look into malware and malicious content. I do the platform protection. I do the host protection, and then I do intrinsic, which is not in-depth with agent running protection for the containers and for the serverless applications. An example here, which comes to the same that we saw before, is just basically that when I'm committing building, I'm pushing it, I'm putting it into my registry. My solutions will analyze the content inside, and once they do the detection, they're going to come with an alert if there is something to mention and bring it back, telling me, Jesus, what you pushed is not good. So go back, check what you've done, rebuild, recode, fix it, rebuild, push it again, and I'll see if it passed. And if it passed, then it goes directly to the orchestration and to the running stage. A use case, for example, in the case of a pipeline would be the fact that people will use open source. They will reuse code that was already vulnerable and that was already badly written. There will be package dependencies that I don't have the control of, where when I'm using a package, it will just claim more packages under it that will have a lot of risks, and I don't have the ability to see those risks, and that is going to create the situation where I'm pushing something, thinking I'm doing it right from my standpoint, but not knowing that I probably either content that I used was hacked externally. So when I pulled it and used it, it was already infected, or somebody did a lot of mistakes in the code, and I just keep on reusing it because I joined the team 1 year later or time after that particular code was built. So when we look into the mitigation, this is when we also have different, what we saw before about the processes that you need to follow as a framework. Then we need to look into what could we mitigate in this process of CI/CDs. We should do vulnerability assessments. So we look for local and potential remote exploits. We need to do vulnerability shielding, which means that I need to make sure that when I'm running it and exposing it is not exposed openly, it is actually protected. I need to make sure that the code does not have, my built applications do not have malware running. So I do it by machine learning and signatures whenever I can, whenever the solution approves it. I need to continuously scan everything, either my repository of code, my registry of images to make sure that there are no malicious images running, or that my images. Something very important to know about cybersecurity is that what was not visible today in a month's time could appear as detectable as bad. That's the reason why we still have hacks in the world, is that the majority of the 0 days exploited today are undetectable. And when you find a 0 day time later, you think like, wow, look at everybody who was infected in the past. And that's the reason why you need to continuously scan, because you could raise flags using retro feedback about images that you thought that they were clean, or libraries that were clean, that were infected but undetectable, and X time later, they're actually detected as malicious. You need to scan the data historically. So that's what I said about the immutability of the logs, and having an historical analysis to have the behavior and creating a pattern across time. Obviously, making sure that what is the first characteristic of a container? Immutability. It doesn't change. The image doesn't change. We need to make sure that that's happening. And obviously, we need to have an automation in security. Takes point at the end of the slide and the end of the speech and the talk. The idea is that the CI/CD security landscape keeps on changing all the time. We can infect anything. Apps with vulnerabilities, libraries can be infected, images, registries, hosts, and the pipeline can be infected from the developer, even in the beginnings, up to the end when everything is committed, built, and running. Docker images, for example, are a very good example that every year that there is a Black Hat conference, they demonstrate a new way to vulnerate images and present malicious images all the time. So what you need to bring into your environment, not only on top of the framework, you need to put a set of solutions or security solutions that are looking into, as I said before, all the code analysis, and on top, the anti-malware, non-signature based. So we don't want things based on signature. We want things that are anti-malware solutions that are looking into malicious code and malicious processes by analyzing the behavior. Behavior analysis and monitoring, machine learning and AI on top of it, if possible, vulnerability analysis and vulnerability shielding, and sandboxing, which means that when I find something that could be potentially malicious, I want to detonate it in a safe environment. I would see the behavior and I take a decision based on the scoring at the end. And the ecosystem, as I said, take this formula, which is the adds of DevOps and of Devs and Ops minus all the integration of the security solutions. So the first part is bad. The security just reduces the value. Thank you very much. I think I did a little bit longer. Probably was like 15 minutes longer.
Shall yeah, that's we are a little bit running over time. So apologies, we're not going to have time for questions, but thank you so much, Jesus. I guess people can reach out to you.
Absolutely. Anytime.
Fabulous.
Anytime. All right. You know me, my email is open and I'm 100% accessible. I'm not a very difficult person.
Okay, thank you. Can I ask you to stop sharing your screen?
Yes, first? Indeed. Done.
That concludes our meetup tonight. So thank you so much for joining us on Cloud Native London, whether you're watching on YouTube or Twitch, or you've joined on Rambly. I'm going to hang out there for a few more minutes to just chat to people. So if If you want to come and chat to me, please go to oishell.com/r, and I will see you again next time on the first Wednesday of February. Have a great night, everyone. Thank you and take care. Bye-bye.